All right, number 1 asks for what value of x is the quantity 2 times x plus 3 plus 4x equal to 3 times the quantity 2x plus 1. So it's helpful here to translate this into a mathematical statement. Essentially what we're looking for is the solution to this equation. We see that there's some distribution that needs to happen. So 2 needs to get distributed into the quantity x plus 3. It gives us 2x plus 6, and then we have the plus 4x. On the right-hand side, 3 needs to get distributed into the quantity 2x plus 1. That gives us 6x plus 3. On the left-hand side, we do see some like terms, so that 6x plus 6 is then equal to 6x plus 3. Here I notice that there's a 6x on both sides, so if I subtract 1 to the other side, or so right to the left or left to the right, either way, we're getting that those 6x's cancel one another out. And we're left with the statement 6 equals 3. So since we know that 6 does not equal 3, and that this is a false statement, that implies that there is no solution. Meaning there is no value of x such that this quantity is equal to this quantity. Number 2 is a little bit tricky. We're almost set up to answer it incorrectly just by how it is worded. So we're asked to find the slope of the line defined by this point in this equation. Now this equation reads mx minus 3y equals 11. And why I said that we're kind of set up to answer this question incorrectly almost from the beginning is because of the use of this variable m. When we think slope, we often associate that with the variable m. However, this value here in front of x is not the slope because this is not in slope-intercept form. This is an equation in standard form. We can take the coefficient to x, the number in front of x, to be the slope only when y is isolated. So notice here y is not isolated. So we actually need to figure out what the value of m is first, and then convert this to slope-intercept form in order to identify the slope. So we're given the point 4, -1. So we know that x is 4 and y is -1. So we can take the equation m times x minus 3 times y equals 11 and substitute that point in. So 4 is going to take the place of x. That will give us 4m minus 3 times -1 is equal to 11. Simplifying and solving gives us 4m plus 3 equals 11, and then 4m equals 8. Finally, m equals 2. So a lot of us said that the slope is equal to 2, and I understand why. I understand the reason behind that, right? We are, again, condition ourselves to use the variable m to identify slope. But let's pause and recognize that this value is just then going to replace the m in this equation. So this equation is actually 2x minus 3y equals 11. And hopefully as soon as we write that, we recognize, oh, that this cannot be the slope, right? The slope is only the coefficient to x when y is isolated and on its own. So we'll go ahead and work to isolate y by subtracting over the quantity 2x. We'll get -3y is equal to -2x plus 11. Divide out that -3, and that will give us y is equal to positive 2/3 x minus 11/3. So here we just have to mind our negatives, right? We have the -3 divided by -2 divided by -3 gives us a positive 2/3. A positive 11 divided by -3 gives us a -11/3. So here we are in slope-intercept form. We can identify that the slope is actually 2/3 rather than 2. Question 3 is talking about Mary and the dogs that Mary walks. So Mary walks at least 6 dogs and at most 12 dogs each morning. Sounds like a very busy morning if you ask me. Based on this information, we're trying to figure out the possible number of mornings it could take Mary to walk 24 dogs. So I think for this problem, it's easiest just to kind of collect some notes. So on day 1, she's walking between 8 and 12 dogs. Day 2, that total of dogs that she's walking is going to be between 16 and 24. Right, because we have one more day, so we need to double this kind of range from day 1. Similarly, for day 3, we're going to triple that original range, right? Somewhere between, she's walking between 24 dogs and 36 dogs. So the question was asking us, what is a possible number of mornings it would take Mary to walk 24 dogs? Well, we see 24 dogs in both day 2 and day 3. So we can say either 2 or 3 days or mornings. But either one of those is going to get us those 24 dogs walked. Number 4 is looking at 2 equations. We have one line, y is equal to m sub 1 times x plus b sub 1, and y equals m sub 2 times x plus b sub 2. So this first equation, it has a slope and a y-intercept. We have the second equation has a different slope and a different y-intercept. We are told that these intersect and form a right angle. So it's helpful to kind of think about, well, what does that mean? If these lines intersect and form a right angle, that means that these lines are perpendicular. And when we think about perpendicular lines, we know that the slopes are opposite. So opposite is instead of positive or negative, or instead of negative or positive. So these slopes have to be opposite, and they also have to be reciprocal. So reciprocal is that flip of a numerical value. So if I wanted to take the reciprocal of 1/3, that is 3. If I wanted to take the reciprocal of some value a, that is 1/a. Excuse me. So I'm looking at m sub 1 and m sub 2 when I'm considering this question. So right away, I can ignore answer choice B. That's looking at the y-intercepts, and the y-intercepts are not opposite reciprocal if lines are perpendicular. We also know that if lines are perpendicular, slopes cannot be equal. They're not going to be the same thing, so answer choice A is out. I see in answer choice C and D some good things. So if m sub 1 is said to be equal to 1/m sub 2, that means that m sub 1 is equal to the reciprocal of m sub 2. Now that's great, except it's not enough, right? We need it to be opposite. So we'll see that answer choice D is actually correct. And it looks like there's some typos in my answer choices. It looks like this should actually be m sub 2 is equal to m sub 1. It looks like it kind of copied and pasted and should have changed up those subscripts. So I apologize if that caused unnecessary confusion. All right, 5 is another really good one. A little bit kind of tricky, easy to answer incorrectly. So a lot of us took a look at this compound inequality, which was a great first move, right? Looking at negative 17 being the lower bound of the quantity 3 minus 5, and 16 being the upper bound. And we did a nice job of solving for A, trying to figure out what are the restrictions on A. So adding the 5 to both sides of the inequality gave negative 12 less than or equal to 3A less than 21. Finishing that up with division by 3 tells us that A can be 4 or a value greater than 4 as long as it is also less than 7. Okay, so A can be any number in this range. It can equal negative 4 and any value up until but not including 7. Now, what gets tricky is what is supposed to be an integer. We're asked what is the greatest possible integer value of 2A plus 3. Okay? A does not necessarily have to be an integer value. We're investigating 2A plus 3. So I'm trying to figure out 2A plus 3, which of these values, what is the largest value it could possibly equal such that A satisfies this constraint. So since I'm looking for the largest value, I'm actually going to try the biggest answer choice. I'm going to see what happens if I let 2A plus 3 equals 16. Quickly solving, I see that that means that A is equal to 6.5. Notice, A equaling 6.5 falls within this range. It's okay that A is not an integer. We want this quantity to be the integer. So our answer here is 16. A lot of us chose 15 because I think we were anticipating that A should be an integer. So setting 2A plus 3 equal to 15 gives us 2A equals 12 and A equals 6. So A here is an integer and also falls within this range, but notice A can be a little bit larger and not an integer, right? It doesn't say that A has to be an integer, and that actually allows us to get this quantity 2A plus 3 to be 16 rather than 15. Since 16 is larger than 15, we choose that as our solution. Again, in a big place for maybe a small mistake is just thinking that A had to be an integer. This is a fine value of A because it lies within this restriction given to us from the original compound inequality. And notice this does not say that A must also be an integer. Okay, number 6. We are told that if 6 more than x is less than 9, or 3 less than x is greater than 7, which of the following is not a solution? So again, here's another example of something that would probably be good to translate into a mathematical statement. So if 6 more than x, so if I take x and add 6 to it, is less than 9, or 3 less than x, so I take x and subtract 3 from it, is greater than 7, which of the following does not work? So in order for this to not be a solution, in order for one of these to not work, it has to fail in both of these statements. Okay, so you would take a look at these values and test them out into both of these statements. Whichever fails both is not a solution. Okay, so it ends up being that 7 is the non-solution. Notice if you plug 7 into this first inequality, we get 7 plus 6 less than 9. 7 plus 6 is 13, which is not less than 9. And then when we plug 7 into the second inequality, 7 minus 3, is that greater than 7? Well, 7 minus 3 is 4, and 4 is not greater than 7. So we know that 7 is not a solution to this compound inequality. All right, number 7, we are given the system of inequalities and asked to determine a relationship between A and B. So to be honest, I struggle with inequalities, and I find it really, really helpful to kind of write out in words what this means. This first statement tells me that y is smaller than the expression or the quantity 2x minus a. The second statement tells me, though, that y is also bigger than 2x minus b. So y is smaller than a certain quantity, but bigger than another quantity. So I can think about y having to exist between 2x minus a and 2x minus b. Notice that this still tells me the same information that I kind of translated up here, right? Y is bigger than 2x minus b, which was from this second statement, and y is smaller than 2x minus a, which comes from this first statement. So y is in between the quantity 2x minus b and 2x minus a. What that allows us to do is just focus on comparing 2x minus b and 2x minus a. From this compound inequality here, we know that 2x minus b must be less than 2x minus a. We see a 2x on both sides, so we can think about kind of combining like terms, but in doing so, we see that the 2x's cancel. We have the statement negative b is less than negative a. Looking at my answer choices, I don't really have any statements that support those negative variables, so that might encourage me to divide out that negative or multiply out that negative. In doing so, please remember we have to change the direction of that inequality symbol. So we see that B must be larger than A, and that is answer choice B. Question 8 is a little bit tricky because the variable that we're trying to solve for is in two different terms. So we want to get m by itself, but right now m is in two different places on two different sides of the equations. Excuse me. Hopefully I kicked that cough pretty soon here. So we have d minus m is equal to m times r times x. So if you said, Mrs. Bossy, get m alone, I'm going to struggle with that because I don't know which one you're talking about. So a good first move is to combine that variable, or push that variable to the same side. So we have d is equal to m plus m rx. Now it's really tempting to try to push these two terms together, but notice they are uncommon. They are not like terms. This is m, and this is m being multiplied to x and r. So I cannot combine this into 2m rx. What I can do, though, is recognize that there is a common factor of m between these two terms. So that allows me to divide out the m on the right-hand side. That leaves behind a 1 plus an r times x. And in those moves, what I've done is I've isolated m, or I've kind of introduced m to exist just on its own. So m is being multiplied to this quantity. If I want a statement that says m equals something, that means I need to divide out this quantity that it is being multiplied with. So I will divide out the quantity 1 plus rx, and that gives me m is equal to d divided by 1 plus rx, which is our last answer choice here. All right, team, last one. If the sum of two integers x and k is less than x, which of the following must be true? So lots of information out in words, answer choices in mathematical symbols. So that kind of nudges me to translate that statement, the information that I'm given in words, into a mathematical statement. So let's start with the sum of two integers x and k. So I know I'm taking x and adding it with k. Must be less than x, so less than x. And I need to figure out which of the following statements is true. So looking at this statement and the answer choices, it looks like I should probably try to manipulate this sum. Recognizing that there is an x common to both sides, I can work to combine those terms, and I come up with k is less than 0, which is answer choice A. All right, I hope you found this somewhat helpful. If there are questions that came up for you while you watched this video, please send me an email or comment on Google Classroom. I'm happy to do another video for you trying to clarify a little bit more, or we could maybe chat over email on anything you found confusing. But let me know what I can do to help support you.